students, welcome to the video lesson on Relational Database Management System. I am Mrs.P.Avila Clemenshia, Assistant Professor, Department of Computer Science, Nirmala College for Women. Under Relational Database Management System, the topics we are discussing in this video are theoretical relational languages, relational algebra, and operations of relational algebra.
Relational languages provide more power with very little coding. The relational languages are classified into relational algebra and relational calculus by E.F. Codd. So, the relational languages provide the basis for SQL. Relational algebra is a procedural query language which takes instance of relations as input and produces instance of relations as output. It uses set operations on tables to produce new resulting tables. The resulting table is being used for subsequent sequential operations. It uses operators to perform queries. An operator can be either unary or binary. Relational algebra is performed recursively. Intermediate results are also relations. Fundamental operations of relational algebra are union, intersection, difference, selection, projection, product, assignment, and join operations. Union operation. Union is one of the set operations which can also be performed on relations, and all the set operations can be performed on relation as relation is also a set. But when we perform set operations on relations, it is essential to satisfy certain criteria. This criteria is called as union compatibility. Two or more relations are said to be union compatible if the degree of the relations is the same. What is the degree of relation? It is that number of attributes present in the relation. For union compatibility to hold, another condition must be satisfied. Say, R1 and R2 are two relations, then the ith attribute of relation R1 should have same domain as the ith attribute of relation R2. R1 union R2 is nothing but the union of instances R1, R2, which results in tuple T, which is a tuple in relation R1 or tuple in relation R2. Here we can see how the union operation is performed between two relations, namely student and project student. Student relation and project student relations each has two attributes, register number and name. To perform union over these two relations, they must be union compatible. It is clear that the two relations have the same degree, that is, two attributes each, and each of the corresponding attributes have the same domain. This implies that they are union compatible. Secondly, union operation retrieves all the rows from the two relations, student and project student, which is the resulting table. It needs to be noticed that the resulting table has no duplicate rows. That is, the resulting table cannot have any duplication. This is how the union operation is performed. Similar to union operation, intersection operation is simple to perform over two relations. Here, our two relations are student and project student relations. The intersection symbol is the same that we use for the set intersection operation. To perform intersection over the relations student and project student, it is necessary for the relations to be union compatible. Union compatibility is that same rule that we have already discussed for the previous operation. We see that these relations are used in our union operation and they are union compatible with true attributes each and having the same domain for the corresponding attributes. The intersection between two relations is performed to retrieve all the rows that are in both the relations. In our example, the first two records of student relation and the first two records of the project student relation are the same. And so, we see those two records in our resulting table. In order to carry out the difference operation between two relations, the union compatibility rule is in effect as for our union and intersection operations that we just discussed. The purpose of difference operation in R1 difference R2 is to retrieve all the rows that are in relation R1 but not in relation R2. It is noted using a different symbol. We see our same example, student and project student relations that are union compatible. Here, for student and project student, the difference operation between them would be the last two records of the student relation, which is not present in the project student relation and hence is returned as a result of the difference operation. It is important to understand that R1 minus R2 is not equal to R2 minus R1. Projection operation. It is a unary operation that requires a single relation to process. This projection operation enables to retrieve only the desirable columns from all the existing columns of a relation. The result is a vertical slicing of the given relation. In this example of student relation, the projection operation performs the vertical slicing and returns the relation with just register number, which is the desired column to be retrieved as an output. Selection operation. It is used in a relation as a unary operation that retrieves rows from a relation based on one or many conditions. The conditional and or logical operators are used to generate such conditions. Selection operation returns horizontal slices from a relation. Here, the student relation is used to select the particular student record with register number as given by the user, and the result of selection is that horizontal slice of the student relation. Product operation. This is also known as Cartesian product of relations. This operation results in the combinations of all records in both the relations. The resulting relation has x into y rows and m plus n columns, where x and y are the number of rows and mn are the number of columns of the relation 1 and relation 2 respectively. In this example, the Cartesian product of employee and project relation results in a relation which has 6 rows, which is the product of number of rows of employee and project relation. The resulting relation has 4 columns, which is the sum of the number of columns of employee and project relations.